Okay, we will continue our lecture on the bolt and nut design procedures. In the previous lecture, I kind of generalized the procedure here. How do we design the bolt and nut? And that's a general procedure here that we went over. Today I'm going to give you an example here, and this example is on the book, page 43. Page 43. It's going to be here, page 43. Okay, page 43. This example here. If you have a book, you can look at this example here. And so what it is that we have a pillow bracket for a bearing, and that connect to the machine mainframe use two screws or two bolts. And that's a very common design in an automobile, that in your car you can see like your generator, your water pump, they're all kind of connected to the engine block in this way. Use bolts and nut connect to your engine block. So that's a very common design here. And we need to figure out what size of the bolt we're going to use. And so that's what we need to figure out here. And the initial loading, tightening torque, those are the things that we need to figure out. Now, you can see the load is 9 kilonewton. That is shared by two bolts here. So we're going to take a look at this. Okay, we're going to take a look at this. And the material here, you probably can't read it, but if you turn to this page 404, the material we use is class 5.8. Class 5.8. If you turn to page 393, okay, turn to page 393. There's a table here. This table here, and this table, this one is for standard threads. This one is for metric, and this problem is a metric. So you can see class 5.5. The book says is inexpensive material, 5.5, and dimension is 5 millimeters through 24 millimeters. The proof strength 380. Okay, so that's page 393. Page 393. Now we're gonna take a look at the problem here. So page 393, from last week's lecture, we're gonna put this formula here. Okay, proof strength, page 393, where you find the proof strength. Now, the proof strength is less than yield strength, less than tensile strength. Certainly, yield strength less than tensile strength. We need to proof strength is about 90% of yield strength. We want to use a little bit lower strength as a criteria to design the threads, because we don't want anything wrong with the threads here. So that's why we use proof strength in bolt and nut design. We use proof strength in bolt and nut design. Okay, so we're gonna do this problem here. We have 9 kilonewton divided by two screws, and that's gonna give us 4.5 kilonewton each. And the book uses a safety factor of 4. Safety factor equal to 4. So the design load will be 4.5 kilonewton times 4 equal to 18 kilonewton here, equal to 18 kilonewton. And that's the load. Now load divided by area, and that's going to be the stress. That's going to be the stress, right? And the stress, the load is 18 kilonewton divided by area. We don't know, and we don't know. That's area, tensor area. We don't know. And this should equal to, this is stress here, this should equal to proof strength. Proof strength. And we know proof strength is 380 megapar. Okay, and so we kind of expand that. If we have 18,000 Newton divided by AT, if this is in millimeter square, we know then that's gonna be megapar. Newton divided by millimeter square is gonna be megapar, so it's gonna be 380 megapar. And then we have AT, which is tensor area, is equal to 380 divided by 18,000, and the unit will be millimeter square. And that's gonna give us 47 millimeter square. 47 millimeter square. Okay. Now, if you go back to page 376. Page 376, and you have the dimensions, basic dimensions of metric stress. 375, you have standard dimensions, okay? So we go to 376, and we find out, okay, there's no AT. If you take a look at AT here, stress area AT, there's no 47. The next up is 58. So you got to use the next up. You don't go down, you go up. And you go up, next up is 58. So next up, the tensile stress area, AT, is equal to 58 millimeter square. And this one here, next up, 58, and it's a metric M10 by 1.5. So you have M10 by 1.5. M10 by 1.5. So this the size of the boat that we decided. Now once we have size of the boat decided, and then we know the AT is 58 millimeters. Now we're gonna use this value. We don't use this value anymore. We're gonna use this value. That's what we choose here. Okay, that's the size. Now with the size decided, we need to find out the initial loading. And certainly initial loading, Fi, is equal to 0.9 times AT times SP, proof strength, Okay, and once we find out the initial loading, we can find out tightening torque. And T is equal to 0.2 Fi times D, which is, D here in our case is 10 millimeter. And then we can find out tightening torque. Let me see if the book go into that. Yes, okay. So, and the book calculates this one here, which is 19,000 Newton. 19,836 Newton. And that's very simple here. You just plug in 58 here, and plug in 380 here, plug in 58 here. You got this number here. Now D is 10 millimeter. Then you have torque. You find out the torque is 39.6 Newton meter here. Okay, actually this number is not It's not, this one here is 0.2 times 19,836 times 10, that's equal to 39,600, about 39,600. But this is Newton millimeter, and then divided by 1,000, you got 39.6 Newton meter. You got 39.6 Newton meter.